Good morning and welcome to your Unit 2, Lesson 5 Notes on Solving Multi-Step Equations. By the end of the day, you'll be able to solve equations involving more than one operation. So remember when we talked about wrapping a present, first you close the box, then you wrap with paper, and after that you tie the ribbon in a bow. You tie a bow. So you have steps 1, 2, and 3. But to undo that, first, change all these from what they do to what they undo. So to unclose the box is the same thing as to open the box. And to unwrap the paper is a real thing, so we'll leave that alone. And then, wrong part. And then finally, to untie the bow is a real thing. However, if I tried unwrapping a present using the steps in this order, this would be totally wrong. Instead, we need to take the order and we need to go backwards. So instead, we start by untying the bow, and then we unwrap the paper, and then we open the box. So everything that we have going on, we undo in backwards order. That doesn't only apply to unwrapping a present, that also applies to putting on socks and shoes. For example, my first step this morning in putting on my socks and shoes, I first put on socks, and then I put on my shoes. However, to undo that, what am I going to do first? My very first step in taking off my socks and shoes is going to be to first take off my shoes. And then once I've done that, then I can take off my socks. So, how do we undo something? If you want to undo an operation, you need to reverse the order. And that's what we'll be doing today. So the order that we like to follow in math is called PEMDAS. Do you remember that? What does P stand for? P is parentheses, which are things like this. Sometimes you'll see brackets, sometimes you'll see braces like that. After P comes exponents, which is when you have, something raised to a power. And after that you have multiplication and division. And we do multiplication and division from right to left, however they appear. And then finally we have addition and subtraction. Did I say from right to left? Because I totally meant from left to right. Good thing I wrote it down. Addition and subtraction, the same step from left to right as they appear. Okay. Now our main idea of the day, love it, star it, commit this to memory, is that to solve a multi-step equation, you need to undo what's happening to the variable. You need to undo the order of operations in reverse order. So that means we'll take addition and subtraction, and we will undo that. We'll take addition and subtraction, and we will undo that first. And then we'll undo all the multiplication and division that's happening to our variable. After that, we'll undo our exponents, and then after that, finally, we undo our parentheses. So let's put it into practice. In our first one, we have x over 4 plus 5 equals 25. So remember, reverse PEMDAS will give us addition and subtraction, multiplication and division, exponents, and parentheses. So we need to undo this plus 5 first. So to undo that, we minus 5 on both sides, which gives us x over 4 equals 20. And then we need to undo this divide by 4. To undo divide by 4, we're going to multiply times 4 on both sides, giving us that x equals 80. Ta-da! Let's do another one. Keeping our reverse PEMDAS in mind, first we're going to undo addition or subtraction. Here we have that right there. So to undo the minus 8, we are going to add 8 to both sides. That gives us that 3r equals 15. Now what's happening to our variable? Now we have 3 times. So to undo that 3 times, we're going to divide by 3 on both sides. On this side, the 3's cancel out. That's the whole reason that we did that. And we're left with r equals 15 divided by 3, which is 5. Is that fantastic? So fantastic. Now we've got a word problem. So first we're going to write an equation, and then we're going to solve it. So the Lockheed SR-71 Blackbird, which is a spy plane during the Cold War, has a top speed of 2,200 miles per hour, which is 475 faster than 3 times the speed of a typical commercial flight, which is like if you fly, like if you go on a trip, that's how fast you're going. So find the speed of a commercial flight. Well, what do we know? We know that the speed is 2,200. We also know that it's 475 miles per hour faster, so that'll be 475 plus something. And then finally we end with 3 times our typical commercial flight. So that 3 times is pretty easy to translate to math. That's 3 times. And then whatever our commercial flight is. We want to find the speed of a commercial flight, how about we just name that C? Sure? Sure. So let's set it up. And we forgot one key word. Our key word is. Is means equals. So to translate that, we're given that 2,200 is 3 times, oh no, I skipped one, 475 plus 3 times our C. So now that we've got our equation, let's solve it. First, we want to undo any addition or subtraction that's happening. So the addition and subtraction that's happening first is 475 plus. So to undo 475, we are going to subtract that guy away. We subtract 475 from both sides, and we are left with 1725 on one side equals 3C. Next, we have 3 times C. So to undo 3 times C, we're going to divide by 3 on both sides. And that gives us, here the 3's cancel out, so we have just C. That's 575 miles per hour. Cool, huh? Now to help you with our last kind of problem, I'm first going to define something for you. A consecutive integer, whenever you have consecutive, that means in a row. So consecutive integers are integers in counting order. So you have like 1, 2, 3, 4, 5, 6, that right? Those are consecutive integers. You can have like 18, 19, 20. Those are consecutive integers. You can have like -8, -7, -6, things like that. Okay, so consecutive means in a row. So I'll ask you to find numbers in a row. And how you find that is if you want to find all the numbers in a row, you start with one number, and then to get the next one, you add 1, and to get the one after that, you add 2, etc., etc. For example, if I said, find consecutive integers starting with 2, well, that would be 2, 2 plus 1 is 3, 2 plus 2 is 4, and so on. What if I want you to find even integers? Then you take your starting one, and then you add 2. And from there, you add 4. Why does this work? Let's say we're starting with 8. The next even number is 8 plus 2, which is 10. And the next even number is 8 plus 4, which is 12. And so on and so forth. But guess what, guys? To find odd integers, it's the same pattern. So if you want to find odd integers, that's odd numbers in a row, and you start with like 3, for example. The next one is 5, because that's 3 plus 2. The next one is 7, because that's 3 plus 4, and then you move on. So, what if you want to find 3 consecutive integers whose sum is 21? Well, that's consecutive integers. We're not saying even or odd, so we start with this. So we say, well, n plus n plus 1 plus n plus 2, that's going to be equal to 21, because you have each of these numbers, n plus 1, n plus 2, you add them up, you get 21. Now that's great, but now what do we do from here? Here, you're going to add up all the n's. How many n's do you have? You have 1, 2, 3 n's. So that's the same thing as 3n plus, and then how many leftover numbers do you have? 3. 3n plus 3 equals 21. Now that we've got our equation, we can solve it for n. First, we're going to undo the plus 3. So we minus 3 from both sides. We have 3n equals 18. Divide by 3, divide by 3. N equals 6. But we're not done, because that's just our starting point. Remember, we need 3 numbers. But our starting numbers were n plus 1, and n plus 2. So all we need to do is find out what's n plus 1, which is 7, and what's n plus 2, 8. So our 3 numbers in a row are 6, 7, and 8. Cool, right? Cool. Let's do it one more time. This time we want to find 3 consecutive even integers whose sum is 42. So to find even integers, instead of adding 1 and 2, we're going to add 2 and 4. So we have n plus n plus 2 plus n plus 4 equals 42. How many n's do we have? We have 1, 2, 3 n's. So here we have 3n plus, how many leftover numbers do we have? 2 plus 4 is 6. So 3n plus 6 equals 42. Now to solve this equation, we want to subtract 6 from both sides, giving us that 3n equals 36, and dividing by 3 on both sides, n equals 12. Now remember, because we're looking for even integers, we want to find numbers that follow this pattern. And all we found was our n. Right now we know that n is 12. Wrong one. Hi guys! Hi. I have some friends coming in my room. So here we go. We've got bonus friends on our lecture today. So that tells us that n is 12, and 12 plus 2 is 14. And finally, 12 plus 4 is 16. So our 3 consecutive even integers are 12, 14, and 16. So our key idea of the day is when you're solving equations, you need to undo your order of operations, but reverse the order. Hope you have a wonderful time on your homework.